Okay, today I'm going to talk about another geometry problem, this time from Australian Mathematical Olympiad from last year. So the problem is as follows. So basically we have two circles that are intersect each other at points A and M, and we draw two tangents to these circles at point A. So to the first circle and to the second one. They intersect these circles the second time at points D and B, as shown on the picture. Then we draw the line AM and choose the point C such that AM is equal to MC. And then, so basically that's it, and then we consider the quadrilateral ABCD, and we need to prove that it is cyclic, which means that these 4 points lie on the same circle. So let's examine the solution to this problem. So first let us notice that angles ABM and DAM are equal to each other. So this is basically because they are both subtended by the arc AM in the right circle, in the second circle. So then we observe a similar equality of angles, that the angle ADM is equal to BAM. This is because they are both subtended by the arc AM, but this time in the first circle, in the left circle. And so we notice this. Then we calculate the angle CMD. So we notice that this is an external angle in the triangle AMD. Therefore, it is equal to the sum of the other two angles at the other two vertices in this triangle. So it is equal to the sum of the angles ADM and DAM, which is equal to alpha plus beta. Now we calculate in a similar manner the angle CMB. So it is equal. It is an external angle in the triangle ABM, and it is also equal to the sum of these two angles ABM and BAM, which is also alpha plus beta. As established before, we proved that the angle ABM is equal to DAM, and we introduced this angle as alpha, and ADM is equal to BAM. We introduced it as beta. So at this point we notice that these two angles CMD and CMB are equal to each other. We calculated they are both equal to alpha plus beta, so they are equal to each other. So now let us notice that the triangles AMB and DMA are similar to each other, and this is simply because of the equality of angles that we established earlier. So they have two pairs of corresponding equal angles, therefore they are similar. So, but from this we conclude that the corresponding sides of these triangles, like the ratio of these sides are equal to each other. So AM over DM is equal to MB over MA. So this means, so now let us go back to the point C, and let us in the problem setting there was the condition that AM is equal to MC. So in this equality that we just obtained, we replace AM with MC. So basically we had AM over dm is equal to mb over am, and we replace on both sides am with mc, because these two segments are equal to each other. Therefore, we obtain that mc over md is equal to mb over mc. So, but from this we can conclude that the triangles CMB and DMC are similar to each other, because well, first because we have these two this ratio of the pairs of sides, and then we have the angle between these two sides, between these two pairs of sides. The angle DMC is equal to CMB, as we established earlier, and it is equal to alpha plus beta. So therefore these two triangles are similar to each other, like by two sides and angle between them. So from this we conclude that they have the other two angles that are equal. So the angle MCB is equal to MDC. We introduce this as x, and the angle CBM is equal to DCM is equal to y. So now let us do some angle calculation. So we consider the triangle CMB, and we calculate the sum of the three angles in this triangle. So it should be 180 degrees, right? So 180 degrees is equal to the sum of these three angles in this triangle, and it is equal to what? It is equal to y plus x plus alpha plus beta, right? So because the angle CBM is equal to y, the angle MCB is equal to x, and the angle CMB is equal to alpha plus beta. This is all from the previous calculations. So this is equal to alpha plus beta plus x plus y. So the sum of these four angles is equal to 180 degrees. So just remember that, and now we consider the following. So we consider finally the quadrilateral that we need to prove that it is cyclic. So quadrilateral ABCD, and we consider the two opposite angles in it, ABC and ADC, and we calculate its sum. So we calculate its sum. So the angle ABC is equal to alpha plus y, and the angle ADC is equal to beta plus x. So in total we have alpha plus beta plus x plus y. So, and this is equal to 180 degrees from the previous point that we established. So we just proved that the sum of the two opposite angles in our quadrilateral is equal to 180 degrees. This immediately implies that this quadrilateral is cyclic, and these four points A, B, C, and D lie on the same circle. That's it.